Alright, so in this question, we're going to talk about a 2016 question 12. It's about statistics, which is the median and the range. So in this question, we have a distribution of the ages of the children in a group. So we have some conditions here. So A must be greater than 11 and 4 is more than B is more than 10. And the main condition that I gave it to you is the median of the ages is going to be 7.5. So you can look at this bar chart. So for this one, for 6, 7, 8, 9, 10, the horizontal axis, which is the age, and you can see some numbers here, the 11A, 11B, and 4. Those numbers are called as a frequency number. So this bar chart can actually simplify as this table. So which means that we have 11 students whose age is going to be 6, and then we have a lot of students whose age is 7, and etc. So that's the basic information of this bar chart. And before we do the question, we can have a quick revision about what's the meaning of the median. So median, to find out the median of a group data, so first of all, the data should be in the ascending order. So which is already now in ascending order already. So because we have 6, 6, 6 for 11th, and then we have 7 for a lot of 7, and then the 8 for 11th as well. So it's already in the descending order. And then we need to pick the middle number. So for example, if my data is 2, 3, 4, 5, 6, then the middle number is this one. So how we think about it? So if we have 5 data, use the calculator, get 2.5, isn't it? Then which means that I need to split it into 2 data, 1 data, and 2 data. So the middle number, the q2, the median, must be the third data. So the third data here is going to be 1, 2, 3. It's going to be 4. Now what if we have 2, 3, 4, 5, 6, 7, 6 data? So 6 data, use the calculator, divide by 2, you got a 3. So it's a whole number, so that we can just split it into 3 and 3. But there's no numbers in the middle, so that we need to take the third data together with the fourth data. We want the middle one, so divide by 2. In this case, we take the 4 and the 5, plus them together, divide by 2, get the median is going to be 4.5. So that's some basic knowledge about what is the median. So now we're going to find out what is the value of A and B. Then how are we going to do it? Because we know that the median is 7.5, so it must be in the middle. So which means that the amount of the student whose age is smaller than 7.5 and whose age is greater than 7.5, they must be equal. So which means that we have the number of the data smaller than 7.5 is equal to the number of data which is greater than 7.5, so that we can just calculate the number of data which is smaller than 7.5, which is 11 plus A. And for those data is greater than 7.5, we can have 11 plus B plus 4. So to solve this equation, to get a simplified version, we have an equation related A and B, so which is A equal to B plus 4. Okay, so because we're giving the condition here is highlighted by red, the A is greater than 11, so we given the A is greater than 11 and B is in between the 4 and 10, so we can consider that A can be 12, greater than 11, so it doesn't count for 11. So the next integer fulfill this inequality is going to be 12. So when A is equal to 12, then B, when A is equal to 12, then B must equal to 12 minus 4, giving you 8. Then we can think about the next case, the A can be 13. So when A is equal to 13, 13 minus 4 giving you 9. But can we try 14? So if you try 14, it's actually greater than 10. But if we minus the 4 here, we can get the B is equal to 10. But however, the B must be smaller than 10. You can't be equal to 10. So this case we don't need to consider. So we actually only have 2 cases, which is A equal to 12, B equal to 8, or A equal to 13 when B is equal to 9. So that's how we solve for part A. Then for part B, now we have 4 more children now join the group. So it's found that the ages of these 4 children are all different. So which means we can't have 6, 6, 7, 7. We can only have 6, 7, 8, 9, 10. And in these 5 ages, we choose 4. And then the range of the ages in the group remains unchanged. So just a quick revision that the range means that using the largest or the maximum data to minus the minimum data. So you can see from here the largest originally is 10 and the smallest, the minimum is going to be 6. So the range here is going to be 4. So if the new student comes in, can it be 5? It's definitely not, because if the 5 comes in, then 10 minus 5, the range becomes to 5, so the range being changed. Similarly, we can have a student whose age is 11, because 11 minus 6 giving you 5 as well, so it's no longer 4, the range is no longer 4. So we must have the ages is in between of 6, 7, 8, 9, 10. Okay? So now the first question is asking that the greatest possible median. To find out the greatest possible median, we need to take the ages of the student must be as large as possible, which means that we need to take 7, 8, 9, 10. And then we can think about the different cases. So we're using the table here for the original data. For before the 4th student comes in, the old frequency is going to be 11, 12, 11, 8, 4. Or we can have the 11, 13, 11, 9, 4, because we have 2 different cases of A and B, isn't it? So you need to separate the different cases. But for both of the cases, we need to add the frequency of 7, 8, 9, 10, isn't it? So it becomes to this lots of the frequency. So for example, the number of the ages 6 students doesn't change, but the 7 changed from 12 to 13, 11 changed to 12, 8 changed to 9, 4 changed to 5. So the frequency number of the ages 7, 8, 9, 10 is increased by 1. Then for the red part, we can consider the first case, which means that A is equal to 13 and B is equal to 9. So we calculate the total frequency first. So we just calculate 11 plus 13 plus 12 plus 9 plus 5, which is giving you 50. To find out the q2, the 50 can split it into 25 and 25. So which means that I need the 25th data plus the 26th data divided by 2. So you can see from here, what is the 25th data? The first 11th data is going to be 6. And the next 13th data is going to be 7. So this 2 adding up is already counted for 24 data, which means that the 25th data must be 8. And the 25th data is 8, then the 26th data must be 8 as well. So 8 plus 8 divided by 2, giving you 8. So similarly, we can calculate the case 2, which is highlighted by using the green highlighter. So when A is equal to 13 and the B is equal to 9, then it both plus 1, so it becomes 14 and 10. So we do the similar thing, we can get the median is still equal to 8, which means that the greatest possible median is going to be 8. Then back to B2. B2 is asking you to find out the least possible mean of the ages of the children in the group. So to get the least possible mean, we want the children that come in, age is going to be as small as possible. So which means that we can take the ages, it's going to be 6, 7, 8, 9, isn't it? But still, we have 2 different cases. We need to consider the A is equal to 12, B equal to 8. At the same time, we need to consider another case, which is A equal to 13, while B is equal to 9. So for the red part, we can consider the case 1 when A is equal to 13, B equal to 9. So to calculate the mean, we need to using the total sum of the age divided by the total frequency. So we have 12 people whose age is 6, so 12 times 6. And then we have 13 people whose age is 7, so you plus 13 plus 7. And then using the 12 times 8, 9 times 9, 4 times 10. So you're adding them up. For the numerator, you got a total sum of the ages. And then you divide by the total frequency, which is 12 plus 13 plus 12 plus 9 plus 4. So you're adding all of them together. Use the calculator, you can get 7.6, which is the case 1. And for case 2, we see it, the green part. We have the A is equal to 14, B is equal to 10. Then as the same, we calculate the mean by calculating the total sum of the age divided by the total frequency. So the total sum is going to be 12 times 6, 14 times 7, 12 times 8, 10 plus 9, and 4 times 10. Then we plus all of the data together and then divide by the total frequency, which is 12 plus 14 plus 12 plus 10 plus 4. Then use the calculator, you can get the median, the mean is equal to 7.615 something. But the question is asking for the least, isn't it? The least mean. So compare this to the 7.6 win because it's smaller. So the least possible mean is going to be 7.6.